Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today, it's recording no? Yeah. Today we are going to start with first PUC chapter Linear Inequalities. Let's first write the chapter name. Linear Inequalities. And this will be for first PUC students. Okay. Now it's a very small chapter, as we know. We have only one exercise and surely we can expect 5 to 6 marks. So I will just say as 4 plus marks. Now let us proceed with the concept first. Very detailed we'll discuss, very short concept, and then we have problems. Okay. Now first, before going to linear, what is inequalities? See, any two real numbers. As I said in the chapter 6, the biggest set of all will be real numbers throughout our first PUC syllabus except complex numbers. Okay. So here, whenever we have any, okay, first of all, what is inequality? When do we say we have what? Inequalities. See, any algebraic expression or two real numbers, any two algebraic expression or any two real numbers related with less than, greater than, less or equal to, greater or equal to. So let's write here any two real numbers or algebraic expression related by any one of this, less than, greater than, less or equal to, greater or equal to. Now how to remember this also? I have spoken long back. Suppose for example less symbol, you can see less than, no? So the less L stylish is here. As soon less than is clear, less or equal to. Since I have got equality, less or equal to. Similarly, how to know greater than? Very simple. GREATERTHAN. Style is G. And you can see this. Okay. So this is what about inequalities. Now coming to this, we have got some types of inequality. Let's first have some example, then we will take that. So some example. If I have two real number, 5 is less than 7. First example. One more. Let's suppose x is more than y. Here what is the difference? First of all, we have inequality. Okay, fine. But here these two numbers are related by the inequality less than. So whenever we have a number, this we call numerical inequality. Numerical inequality. It can happen any one of the four, surely can come, correct? But here you see alphabet we have got. This we call literal inequality. Who knows, for one marker this will be very useful. Okay. I have not used the word inequalities because we have only one inequality. Whenever I have got more than one, I think about all this, at least minimum two, then we say inequalities. Okay. Now in this, let's go for some more. Now I'll be talking about with respect to this differences. Now see this carefully. If I just give you, okay, x is more than 5 or x is strictly less than 5. This, since I have got strictly greater than and strictly less than, this we call strict inequality. When I say strict inequality, okay, strict inequality, when I say, I should not have equality sign, I think, but this two should not be there. Whereas, same question, if I write like this we call slack inequality. I'm saying inequality, not for each I'm saying, okay, together you should say inequalities. So now, whenever we have equality. Next, having understood this, next part will be inequalities with respect to one variable or more than one variable. Now this whatever I have given, no, third, fourth, this is with respect to one variable, and the variable is x. Now we can also have more than one variable, but before that, let us suppose that I have got one more example. 3 is less than 4 less than 5. You can see here we have two inequalities. This we call double inequality. Whenever at a time we have got two inequalities, that we call double inequality. Now this, see this can be like this also. 3 less than 4 less than 5. This is 3 less or equal to 4 less than 5. Or it can be 3 less than 4 less or equal to 5. Or it can be 3 less or equal to 4 less or equal to 5. All the cases. Okay. Then as soon we have two inequalities in the given algebraic expression or between the real numbers, we can say it is what? Double inequalities. Now here we have got for one variable. Now let's suppose that we have got for two variables. So then it can be ax plus by. It can be greater than some number c, or it can have ax plus by greater or equal to c, or it can be ax plus by less than c, or ax plus by less or equal to c. This we call what? Inequalities with two variables. Inequality. Okay, I'll just use our plural now. When I say inequalities, I'm talking about all together. Okay, in two variables. Which are those variables? X and y. Surely, when I'm talking about x and y to be variable, its multiple should not be 0. So surely a should not be equal to 0 and b should not be equal to 0. Both a and b are constant, a real number. As soon any one of them is 0, it will reduce back to this. Nothing but this, not this one. Yeah, this 3. Okay. And c is also a real number. Okay. Now we can also have a quadratic, nothing but non-linear. Now come to this. We are saying linear inequalities, I mean to say. Whenever we say linear inequalities, the variable whichever is there in the inequality, the highest variable should be 1. So you can see here you see power is 1. This comes under linear inequality. Again here power is 1. So all these are what? Linear inequalities. Whereas you see this also what? What's the degree of x and y? Power is 1. Again this comes under the linear inequalities. That's right here. Linear inequalities in two variables. This is linear inequality. This 4 is in one variable and this is in two variables. I hope this point is clear. Let's mention that this is linear inequalities, but this part is in one variable, whereas this one is in two variables. Okay. Now one more. What if I've got degree to be 2? See carefully. I can have something like this: ax square plus bx greater than c, or ax square plus bx greater or equal to c, or ax square plus bx less than c, or ax square plus bx less or equal to c. These all are what? Quadratic. And since I've got inequality, it's a quadratic inequalities. As soon as I say quadratic, highest degree should be 2, and here highest degree 2 multiple is what? A. So a should not be equal to 0. And all a, b, c are real numbers. As the chapter name says linear inequalities, we are going to have a problem only for one variable. In old syllabus we had for two variable also, that is removed I think 2 to 3 years back. Now we are going to have only one variable. We are going to discuss some of the concept now, and then we will take the problems. Kindly make a note. Okay. Yes, dear students, now let us take a numerical problem to understand the basic concept about these inequalities. And whatever we are discussing, it's not only restricted to this chapter. As and when you go for the higher level, I think for second PUC, and whenever math is there, all these are very basic for you. Okay, now see carefully. Let's try to understand with the help of example. First example, 3 and 7. Among this 4, which inequality will suit here? 3 is more than 7 or less than 7? Less than 7. Okay. So either I can write this or this. Understand, when we are writing less than or equal to, understand this. We have option here. It means less than or equal to. Option. That's what now you read less or equal to. You won't say less and equal to. Similarly, greater than or equal to. We have an option here. It can be strictly greater than or it can be equal to. So in place of writing like this, we write together. Similarly, in place of writing separately, we write together. Now, why I am raising this point is, whatever I am discussing, I could have also written in place of less than, less or equal to also. Where we have option. Now, let us understand under what condition these inequalities will remain same and change. So, whatever I am discussing for strictly less than, the same will hold good for remaining 3 also. Okay, we did not discuss separately. So now listen carefully. Let us first go with addition. If we add any number of your choice, think, but don't try to you can give any number, no problem. Let us suppose we are going to add which number? Let us suppose some 4. But I am going to add 4. See carefully. 3 plus 4, 7 plus 4, and I am not going to write any inequality till I don't know what is the value of this. 3 plus 4 is 7. 7 plus 4 is 11. And again, 7 is less than 11. Point number 1. See, here also less than and here also less than. Nothing but whenever you are adding, inequality is not changing. Whenever we are adding, the given inequality is not changing. It remains same. Second example. Same I will take 3 less than 7. Now let's subtract. Or I can say add a negative number. So let us do one thing. Let us fix ourselves to the same number. I want you to understand with the same number just by changing the sign what are the difference we are going to have. So if I add minus 4 on either side. Okay, similarly here also, on either side we have added. So 3 minus 4 and 7 minus 4. 3 minus 4 is minus 1 because signs are different. Sign of this is plus. Whenever signs are different, we have to subtract. So 3 minus 4 is 1. Among 3 and 4, whose larger number? 4 was the sign minus. Again, 7 minus 4. Signs are different. I subtract. 7 minus 4 is 3. Among 7 and 4, whose larger? 7. So sign of 7 is what? Plus. So plus. And we know negative number is less than positive number. Okay. So whatever the inequality we had, same. Summary of the story. Inequality will not change whenever you are going to add any positive number as well as whenever you are going to add any negative number. Okay. Now let us think of multiplication as well. Third example. If we take, again same, 3 less than 4, same number I will take. Now let us suppose I am going to multiply 4, which is positive on either side. When I multiply 3 into 4 and 7 into 4, and again I am going to keep quiet. 3 4s are 12, 7 4s are 28, and very clearly 12 is less than 28. Correct? No? So again, whatever the inequality we had, same inequality is there. But this is when if you multiply by a positive number. I want to quote here itself. When I am saying multiply by positive number, it also means that if I divide by a positive number also, same thing is going to happen. If you want, we can have a cross check. Let's have here itself. Let us suppose, one more, fourth example. 3 is less than 7. Let us divide by one positive number, same, 4. Divide by 4, where 4 is positive, correct? 3 by 4. and here 7 by 4. 3 by 4. Let us divide here. See, 0. If I give 30, 4 sevens are 28. So approximate value of this is 0.7. Come to this. 4 ones are 4. Correct? 7 minus 4 is what? 3. Give dot on here. 4 sevens are 28. This is 1.7. Oh, 0.7 is less than 1.7. So, whether you multiply by a positive number or divide by a positive number, whatever the inequality is the same inequality. No change in the inequality. Sir, what about multiplying by negative? See carefully. Fifth point. Coming to what? Same number, and now I want to multiply by a negative number. So same, multiply by minus 4. If I multiply by minus 4, which is negative on either side, 3 into minus 4, 7 into minus 4, 3 into minus 4 is minus 12, and this will be 7 into 4 is 28. Now what will be the inequality? Many students, as soon as they see negative, no, they will not use a common sense logic. Again, they will think 12 is less than 28. 12 is less than 28, true. But here it is minus 12 and minus 28. For this reason, no. You go with one logic. Surely all the people, no, with respect to amount, no, the brain will work. So here, for I will take as positive both 28 take and 12. Compared to 28 and 12, 28 is larger. So take one amount larger than 28. Don't take very big number. Try to take such a small, easy number, so that subtraction or calculation for you is easy. When choice is I repeat, when choice is given, try to use to the maximum benefit. Don't try to take something a big number and then you have to again calculate it. So I'll take 30. 30 rupees. 30 is larger than this. So now on either side, see this, minus 12, minus 28. On either side, we are going to add 30 rupees. So how much is minus 12 plus 30? Signs are different. I should subtract. So since I'm subtracting, I should get how much? 18. Right? And larger number is 30. So sign is plus. Here also signs are different. So I have to subtract. So I'll get 2. And larger number is 30. So plus. Now, what's the meaning of this? I had 30 rupees. How much? 30 rupees. And I have given, first case, I have given 12 rupees. Since I have given, minus sign. Since I gave a person, how many? 12 rupees. I have got only 18 rupees in hand. First scenario. Second scenario, I had 30 rupees in hand and I gave a person 28 rupees. So how much is there in my hand? 2. So in the first scenario, I have 18. Second scenario, 2. Therefore, here 18 is larger than 2. Nothing but this is larger. How can I say? Whenever you add, inequality will not change. We have understood from here. Correct now? Someone says here we have less, here there we have greater than. That's what I said. Whatever I'm discussing for less than, it is also true for the remaining 3. So, what's the meaning? Greater? Yeah, greater. Yes. So, whenever we multiply by a negative number, inequality is getting reverse. Than saying change, I would like to use the word reverse. It's very simple also, no? See, what is reverse of this? This one. Reverse of less is greater than. Similarly, what is reverse of greater than? Less than. What is reverse of less or equal to? Greater or equal to. What is reverse of greater or equal to? Less or equal to. Reverse. Reverse them. Same thing is going to happen if you are going to divide by a negative number. Let us take that also. 3 is less than 7. So if I divide by what? A negative number 4. So see carefully. 3 divided by minus 4. 7 divided by minus 4. 3 by 4 and 7 by 4 we have already computed. So I can write plus by minus is minus 0.7. Plus by minus is minus 1.7. Again the same logic. Think of a number larger than 2. larger of 0.7 and 1.7, 2 rupees. So you have 2 rupees. If you give 0.7 paise, you will have 1.3. If and here if you give, again you have 2 rupees. If you give rupees 1.7, then you will have 0.3 paisa. 0.3 paisa will be here, no? This will be lesser than this, nothing but I will have greater than. So in short, whenever you are going to multiply negative number or divide negative number, inequality will reverse. So summary of the story, when actually inequality will remain same. Whenever you are going to add or subtract, inequality remains same. Whether it is a positive real number or a negative real number, no problem. But whenever you are multiplying, you have to be careful. If you are multiplying by a positive real number, inequality will remain same. Okay, sorry, remain same. And if you are multiplying by a negative number, the inequality will reverse. Whatever I am saying for multiplication, same thing for division. So what you should remember? Just remember when actually inequality will reverse. Whenever I am going to multiply or divide by a negative number. Otherwise, it will remain same under the operation. Addition, no change. Subtraction, no change. While multiplying, if it is positive real number, similarly dividing by a positive real number, inequality will not change. It will change only if I am going to divide or multiply a negative real number. Okay, is this clear? Fine. Make a note. Okay. Dear students, having understood about addition, subtraction, multiplication and division, now let us move on to what if I take reciprocal. See carefully. Easiest example, 1 is less than 2. What if I take reciprocal? Come on, take reciprocal. One thing you should appreciate that when I am performing any operation, no, for example, reciprocal of 1 is 1 itself. 2, see this. 2 is same as what? 2 by 1. Reciprocal will be what? 1 by 2. 1 by 2 value is what? 0.5 and 1. 1 is more than 0.5. You should appreciate here that when I am performing any operation, I leave this one blank. I won't write anything. I come to the conclusion. Then we are going to go ahead. Okay. So inequality will also change if we are going to take reciprocal. But here you should be careful. Both are positive. Similarly, both are negative. So what about positive, negative? Hold. As in how we go for higher levels in the CET, that time we can discuss. Now whatever is there in the syllabus, let us discuss only that. Okay. One more point I want to highlight. Sir, you said only divide by a positive real number or multiply by a positive real number, divide by a negative number or multiply by a negative number. Sir, you have not talked about 0. See carefully. 1 less than 2. If we think of multiplying by 0, see what happens. What is multiply by 0? Multiply by 0. 1 into 0, 2 into 0. 1 into 0 is 0, 2 into 0 is 0. And here what we are getting? 0 equal to 0. It is completely changing the inequality. Point number 1. Point number 1. Now see carefully again. See carefully. In this scenario, whatever we have, 1 into 0, 2 into 0. Now, if I am going to remove the 0 on either side, remove the 0 on either side, before that we got equality, no? So let equality. Now if I remove the 0 on either side, I will cancel. I get 1 is equal to 2, which is absurd value. We know that 1 is not equal to 2. Now don't say no, I have proved 1 is equal to 2. Why this happened? You have multiplied both the side of inequality by 0. You can multiply this one only if you have got equation, nothing but equality, not for inequality. Because of this reason, we are never going to multiply nor divide by 0. Anyway, for division, 0 is never applicable. For example, definition of rational number, any number of the form p by q, where q is not equal to 0, p by q. The denominator q should not be equal to 0. Both p and q are what? Integer. So always denominator is non-zero. Even in function we discuss this fact. If it is 0, it is what? Undefined. And 0 by 0 form we are discussing limits and derivatives chapter. Okay? Understand. So we are never going to note what? Very important note. Never multiply by 0. Okay, so let us have this note what we have just understood. Okay, what? Note number 1. Whenever we add any real number inequalities, nothing but less than, less or equal to, greater than, greater or equal to, will never change. Many will say, sir, we have just written add. What about subtraction? Be careful. I said any real number. Real number can be positive also, negative also, 0 also. So all the things are covered here. Second point. We'll take as A and B. Whenever we multiply or divide by a positive real number, inequalities. Which are those? Less than, less or equal to, greater than, greater or equal to, will remain same or will never change. Okay, will remain same. Anyway, I have just given other way of saying. B part. Whenever we multiply or divide by a negative real number, inequalities. Which one? Less than, less or equal to, greater than, greater or equal to, will reverse. To be specific, no, reverse to. This less than will change to, let us write in another color. This less than will change to greater than. Greater than or equal to will change to, I repeat, this less than will change to greater than. Less or equal to will change to greater or equal to. Greater than will change to less than. Greater or equal to will change to less or equal to. Okay, be very specific. So with this we are ready. Anyway, for reciprocal, okay, one more point I will just add here, third point. Whenever we take reciprocal between, let's I just have some space, between, whenever we take reciprocal between two positive or negative numbers, inequality, okay, inequalities, less than, greater than, less or equal to, greater or equal to, will what? Reverse. To what? Less will change to greater than, greater will change to less than, less or equal to will change to greater or equal to, greater than or equal to will change to less or equal to. So all the concepts are done. Now we are ready for the problem. Make a note. Well, let us move on to the problems. Concept all discussed. Before I go ahead, let us try to recall number system. We are going to use natural number, integer, whole number, and real numbers. Only those let us list out here, so that no, when we are solving the problem, we should understand which particular element we should include and exclude. Okay. So coming to number system, as we know, the first one will be natural number. Coming to natural number, denoted by n, and it's a counting number starting from 1, 2, 3, 4 and moves on. Next number is whole number. Whole number is denoted by capital letter W, and it starts from 0, then 1, 2, 3 and so on. It's an infinite set. In chapter 6 we have discussed this. Next is integer. So it can be either I or Z. These are counting numbers. I mean to say, these are going to have negative as well as positive natural number, including 0. Now there is no space in this chapter for rational number. So it's ultimately real number. Real number, as we know, it is denoted by capital letter R. And in terms of interval, we are going at minus infinity to plus infinity, open interval. And every interval, don't forget, every interval, let it be open interval, let it be closed at A and open at B, or open at A and close at B, and both close. All these are subset of real numbers. Okay, and both plus or minus infinity does not belong to R. Open interval means value not taken, close means value taken. I repeat, whenever we see this bracket, rectangle, value taken. Value taken. Similarly here also, value taken. Whereas this bracket stands for value not taken. The end value which was given, okay, for both of this. Now having all this, let us move on to the problems. Now what we will try to do as if we solve, no, even though if they have not asked also, we will try to solve for natural number, whole number, integer, so that we are well aware about all this. Okay. Now you may be wondering, what about model question paper number 1? Yes, we are going to take, but in that we had I just saw the first question, 1 mark, that is on double inequalities. So I thought first let us start from basic. So we are starting from model question paper number 2 of these academic year from PU board. Now let us start with the problem. The solution of 3x plus 8 greater than 2, where x is a real number, is. X is a real number. So among all this, they are talking about this. So solution, they said x is a real number and this is the inequality. So I have to solve this. So first, see, don't forget, if this question was like this with equality, to solve for x, you could have transpose 8 the other side, then divide by 3. Here, or the other ways, you could have subtracted by minus 8 both the side. Then after that, you could have cancelled minus 8 plus 8 like this, see, 3x. Subtract minus 8 both the side. Then minus 8 plus 8 got cancelled. Recording, no? Then 3x is equal to 2 minus 8 is minus 6. Then divide by 3. So you get x is equal to minus 2. This same way you can apply here, or you could have transpose. Now see, if I go with the same, no problem. And then I will also talk about without this all how to go about. So since I want what x value, first I am going to add minus 8 on both the sides of the inequality. So we have 3x plus 8 minus 8 greater than 2 minus 8. as you can see that both let us write properly. Both plus 8 minus 8 will get cancelled. 3x is more than 2 minus 8 is minus 6. Now when I'm going to divide by 3, 3 is positive, inequality will not reverse. So I'll get 3x by 3 greater than minus 6 by 3. 3 ones are 3 twos are 3 and 3 gone. So we are going to have x is more than minus 2. Now graphically we can also write. So whatever I'm going to do, graphical representation of or graphical solution of one variable inequalities. Okay. Now see carefully. How are we going to always have a graph? Minus 2 is it? Okay, minus 2. See, right of minus 2, all numbers are larger than minus 2. Left of minus 2, all numbers are less than minus 2. And it's going up to plus infinity here. And here it is minus infinity. The way I have marked minus 2 on the number line, I have not marked because it's just a notation that as and how I move towards the right, I'll get positive. After 0 positive, and I'll just move on. I'll get a very huge quantity. Whereas left of 0, when I see all are negative, as in how I move on here, I get a very small quantity. Okay, so that's what we denote by minus infinity, but it's just a notation. It's not any real number. That's what we are saying. Plus or minus infinity does not belong to R. Now I want more than minus 2. Let us have this habit of plotting also, and even the interval also. See carefully. Minus 2. Since strictly greater than is there, value should not be taken. So open ball. Since more than minus 2 means right. Always whichever number is given, you want more right of that number. You want less left of that number. Okay. So just see. I'm just shading. And mass is what? Open interval. Why open? Value not taken. So for I said, whenever value not taken, open interval. Okay, minus 2 comma infinity. Minus 2 comma infinity is there in option A. So option A is correct. Capital A, sorry. Option A is correct. Now, what is the other way? What I'm saying the other way, no, same problem here. What I'm just trying to say is alternate. Just in place of going for all this working, 3x plus 8 more than 2 is there. No. You just remember, transpose when you do nothing but you're adding a negative term. Inequality will not change. So whenever you transpose, inequality will not change. But whenever you are dividing, you have to just see, means cross multiplying. You have to see whether you are cross multiplying negative number or a positive number. If you are cross multiplying a negative number, inequality should change. Otherwise, it should retain same. Now see this here. I am transposing. 3x is larger than minus 8 plus 2, or 3x is larger than minus 6. Now if when I cross multiply, it means that I am cross multiplying a positive number, inequality will not change. But till you are not perfect, don't go for this approach. Till you are not perfect. Otherwise, this is always best. Okay. But as I said, no. Okay, this is completed. Solution we got. But as I said, no. Let us have answer for this 3 for all this problem. So let I first complete here for the same problem. Let us suppose the question was in place of real number. It was on natural number. Note. We'll take as a note. Problem completed. Some note. If it's a natural number, I want all the natural number greater than minus 2. Surely somewhere here 1, 2, 3 will be the natural number start from 1, 2, 3. So this number, whichever the inequality I got, it should be greater than minus 2. Yeah, all these are larger than minus 2. So x will be all the natural numbers. Okay. Let us suppose it was integer. Okay, whole number. Before that, whole number. So let us suppose the question was on whole number. Then this is the first point. Okay, solution of that. This is the second point. If it's a whole number, it starts from 0. Yeah, 0 will be somewhere here, correct? So x will belong to 0, 1, 2, 3 and moves on. Let us suppose x is an integer. For integer, it should have 0, plus or minus 1, plus or minus 2. But see carefully. Minus 3, minus 4, minus 5 will be here, correct now? But I want more than minus 2. Which are those integer? X belongs to, see carefully, if you want you can plot the number line. Here again, minus 2 is here. This side should be -1. This side we got -3. So here it is 0 and 1 moves on. So all the numbers here, right, are what? Integer. So the answers will be 0, -1, 0, 1, 2, 3, and so on. I just solved this additional. In case if they're asking natural number, whole number, or integer, what should be your answer? I hope this point is clear. Okay, first make a note. Let I erase and make some space for this solution. Make a note. Let I erase this. Hope you have copied. Now let us move on to the next problem. Fill in the blanks. Anyway, this was a 1 marker question. Coming to fill in the blanks. The number of solutions of 24x less than 100 when x is a natural number is. So let's take this 24x less than 100. Since you want x is a product of two terms, so you can divide by 24. 24 being positive, inequality will not change. 24 by 24x less than 100 by 24. 24 ones are 24 ones are. Okay. So 1 by 1 is 1. 1 into x is x. Less than. Now divide this. What will be simplified? If we divide okay, by 2 5 means 50 2 1 2 12 anyway for you calculator is allowed. So if I just divide 6 is dividing 25, 6 4s are 24, then 0.6 1s are 6, enough. So I am going to have 4.1. Okay, 4.16 it is to be still specific. So they ask number of solutions, nothing but all those numbers satisfying this, but it should be a which number? Natural number. So x is a natural number. So natural number. First let us plot this on number line. See, 4.16 is somewhere here. So surely this number is larger than 4. So 4 should be left. And here it should be 5 or 6 on. So I want less than that. So which are the natural number come here? Natural number less than 4.16 will be 1, 2, 3, and 4. That's it. We also have a number less than this 0, 1, 2, 3. I mean to say 0, -1, -2, all that. But those are not natural number. They want a natural number. We have 4 solutions. Nothing but satisfying this inequality. So we have only 4 solutions. Kindly make a note of this. Okay. Okay, dear students, let us move on to the next problem. Question number 34. Solve the inequality and show the graph of the solution on the number line. See, when I say graph on the number line, you are not going to get any graph sheet for this. Just on the same answer script which is provided for you to answer, you have to draw. Okay, that we just did in the previous problem. Now see this carefully. We have been given this. You can see a fraction. See, forever don't think about inequality. If you had equal, what are the steps you could have did? You could have surely taken LCM here because you have a fraction. Same thing. What is nothing is means 1. LCM of 4 and 1 is 4. 4 by 4, 1. That 1, whatever we have got, we are going to multiply here. 1 into x plus 1 is x plus 1. Again, 4 by 1 is 4. That multiply here. Minus 1 into 4 is minus 4. Okay, then here no change. Now very simple. 2 1s are 2 2s are. Nothing but I have multiplied 2 on both the sides. Since 2 is positive, inequality has not changed. Now remaining, this is 1. So what's remaining? 3x minus 4 by 1 will be 3x minus 4 greater or equal to x 1 minus 4 will be minus 3 divided by 2. Now I can cross multiply 2 or I can say multiply 2 both the sides. 2 being positive, inequality will not change. 2 into 3 will be x. 2 into 3 into x will be 6x. Minus 4 into 2 will be minus 8 greater or equal to x minus 3. Solve for x. Now you can transpose x here. And minus here I can transpose. As I said, when you transpose, inequality will not change. Now 6x minus x greater or equal to minus 8 will change to plus 8 minus 3. 6x minus x will be 5x greater or equal to 8 minus 3 will be 5. Now divide by 5, or I can say cross multiply. Okay, I can say divide by 5 on both the sides, and 5 being positive, inequality will not change. So I'll get x is greater or equal to 1. Now I want number line on this. See carefully, 1 is there here. I want all the number larger than or equal to 1. Let it be any number. Larger number to the given number will be right of that number, and left of that number will be lesser than. Why? See carefully yourself. As soon as you plot any number line, as I know you go right, the values are increasing. As I know you go left, the values are decreasing. Even not only from here, you can go this side also. Minus 2 is the next number, integer is minus 1. Okay. So as I know you go to the right, always the number will increase. Okay. So now I want larger than or equal to 1. Very simple from here. Equal is there. So close bar and shade. What's the answer? X belongs to close interval 1 comma infinity. Job done. Okay. Now let us suppose the same problem they have asked for. Note. Problem done, but one note. What? Same problem they asked for natural number, or for integer, or for whole number. See, in all the cases, the larger is standing this side, correct? No? So, since x is greater or equal to 1, the negative integer gone, 0 is gone, whole number 0 is also gone. So, for all this, my x value will start from greater or equal to 1 now. So, 1, 2, 3, 4, and so on. For all these three, same answer. Okay. I just give us a note so that you should also understand what will be the other solution. Let us write this properly. I think while erasing, it just got erased. Okay. Integer I. So with this, this model question paper is done. Make a note. Yes, dear students, now for model question paper number 1, let us solve. As I said, I started with model paper number 2 because you can see here we have double inequality. So I thought first we'll take a simple problem. Now time has come. See, there are two ways of solving this. One, you can split. See this carefully. I feel no need to split. We just think no, middle term. See, in this, no, this contains x. You have to solve for x. Solve for x means you have to make x alone. You have to make x alone. So here, it is 5x minus 3. First remove minus 3. How to remove minus 3? Add 3. Don't write on both sides, we have 3. Okay. So just say add 3. We know that whenever you add or subtract, inequality will not change. So minus 8 plus 3 less or equal to 5x, minus 3 plus 3 less than 7 plus 3. Minus 3 plus 3 will get cancelled. Minus 8 plus 3 will be minus 5 less or equal to 5x less than 7 plus 3 is 10. I want only x. Correct? Now solution without finding the value of x, you can see only x here. So I can divide by 5, 5 being positive, inequality will not change. So minus 5 by 5 less or equal to 5x by 5 less than 10 by 5. So very clearly 5 ones are 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 5 twos are 10. So what we are going to have, minus 1 by 1 is 1, minus 1 less than or equal to x is here, then strictly less than 2. That's it. This is your solution. So just check it out. Oh, is there an option here? Is there an option? No? Yeah. And you also understand one thing. Since in the question you had less or equal to, you can see a question I copied here, less or equal to. Throughout it is less or equal to only. Strictly less than remains strictly less than only. Okay. Let us suppose we had some minus 5 here. When I'm going to divide by minus 5, inequality will reverse, I said no. That time, let's suppose you had minus 5 here. When I'm going to divide by minus 5, less or equal to will change to greater than or equal to, and strictly less than will change to strictly greater than, it will reverse. Okay, fine. Let us suppose now the question note. Let us suppose the question was first one, x is a natural number. Problem completed. I'm just giving extra note. See, if you just plot the number line, -1 is here, 2 is here, 2 is not taken, 1 is taken. Sorry, -1 is taken. So I have to shade this, and this is my answer. Only this. So which are the natural number lying between -1 to 2? 2 is not taken, -1 is taken. Natural number start from 1, 2, 3 on. So the only answer for this case is only 1. Next, second one. Let us suppose x is a whole number. Whole number start from 0, then 1, 2, 3 on. Yeah, 0 will be lying somewhere here, 1 will be lying somewhere here. So surely x will belong to 0, 1. Even for integer also same answer, because it can't go beyond 2, it cannot go less than wait, -1 also is taken here. Forever, let us write it separately. This is for whole number. Now if I take integer, since -1 is taken, x will belong to -1, 0, 1. Okay, this is our extra part for you. Okay, who knows if they ask for this. Okay, now 17 question for 1 mark. Fill in the blanks. If 5x minus 3 is strictly less than 3x plus 1, x is a natural number, the number of values of x. Okay, 5x minus 3 less than 3x plus 1. I have to solve for x. So one side we can bring the x term, other side non-x term, nothing but constant. So 5x minus 3x less than, minus 3 will become plus 3, then plus 1. 5x minus 3x is 2x, less than 3 plus 1 is 4. I want the value of x, so divide by 2. When I divide by 2, 2 is positive, inequality will not change. So 2x by 2 less than 4 by 2. Now simplify. 2 ones are 2 ones are 2 ones are 2 twos are. So x is less than 2. X is less than 2, and don't forget, question says x is a natural number. X is a natural number. So plot on number line. When 2 is here, 3 will be this side, 1 will be here. Correct now? Plus 1. I want only to be what? Natural number. The only natural number which is less than 2 is 1. Here we have 0, -1. These are not natural number. Natural number start from 1, 2, 3 moves on. So my answer is x will belong to only 1. And they asked number of values of x. It's only one value. This is talking about the count. This is the element. Or I can say, since x belongs to this, so x is only equal to 1. Okay, kindly make a note of this. Okay, dear students, let us move on to the last problem from model question paper number 1. Question says, find all pairs, I think what Jody, of consecutive odd positive integers, both of which are smaller than 10, such that their sum is more than 11. Before we go ahead, they talk about odd positive integers. Let us talk about two consecutive. Okay, consecutive they want, right? If I take consecutive, one odd number, let us suppose I take 3. The other odd number will be 5. The other odd number will be 7. Consecutive. Understand here, if I take this one to be x, this is x plus 2. This is x plus 4. I mean to say, to get the next consecutive odd number, I have to take plus 2. So I want only a pair, this 2. So if I assume that the odd number which I want is x, the consecutive, the next immediate odd number will be x plus 2. I hope this logic is clear. Similarly, in NCERT, we have question on even consecutive. So again, for even, if I take this is 2, 4, 6. Again, if this is x, this is what? X plus 2. And again, this is x plus 4. So as soon as you assume x to be odd or x to be even, the next consecutive number will be x plus 2. Okay, so let the two consecutive, they want pair of consecutive odd positive integer, so let the two consecutive odd positive integer be positive integer b x and x plus 2. The logic, I hope, is clear from here. Now let us proceed. I take the other marker. Now let us go to the question again. They said we want pair, fine, both of which, nothing but these two, both of which are smaller than 10. So x is smaller than 10, as well as x plus 2 is also smaller than 10. Next, such that their sum means what? Addition. Sum of whom? There means C, such that there means who? These two numbers. So one more condition. Their sum is more than symbol, greater, more than 11 or more than 11. So just whatever they give in English statement, we wrote in math language. Okay, here I think I wrote wrong here. Lesser than 10, not 0, lesser than 10. Okay, there is nothing to solve for this, it's already solved. If I take the addition, it will be this. Okay, means next number. Now first solve for this. X plus x will be 2x plus 2 greater than 11. Transpose here. 2x is more than 11 minus 2, or 2x is more than 9. Or if I divide by 2, x is more than 9 by 2. 9 by 2 is 4.5. So x is more than 4.5. And here you see, if I solve for x here, x will be less than 10 minus 2. What is 10 minus 2? 8. Okay. So now see carefully. Let us plot on number 9. Here we have 8, 10 and 4.5. So 4.5 is somewhere here. Then 10. Okay, 8 is here. Then 10. This says, okay, this is my first inequality, second inequality, third inequality. Okay, this says less than 8. 8 is here. Open ball, y is strictly less than. Less means what? Left to the number. So this is my solution for the first inequality, second inequality, I mean to say. Here, less than 10. And 10 is here. So again, less than, left to that. Okay. And here, more than 4.5. More than 4.5. 4.5 is here. Let's have an open ball here. And it's moving here. And this is the third. I want common of all. See, where do we have common of all? Where do we have common of all? We have here, which is between 4.5 to 8. But since we want odd number, it is x is equal to, which are the numbers between 4.5 and 8, which are odd number? It is 5. After 5, 6 is the even number. Then 7. That's it. Now, next I want x plus 2. Because I want the pair. The other is x plus 2. Don't forget, one is x, other is x plus 2. Now, add 2 for this. 5 plus 2. See, in place of x, 5. 5 plus 2, 7. 7 is x. 7 plus 2, 9. Okay. I hope it's clear. Now, see carefully. Let us suppose now you forgot to solve this and you have taken next number is what? 9. Correct? No? Next number is 9, because I know many will think, why have I solved this? If I take next number without solving this till 10, x is 9. Put here x is equal to 9. 9 plus 2, how much? 11. But here they said both of them should be less than 10. And this is not less than 10. That's the reason we solved here, and we came to know that this pair will be out. I hope this point is clear. Therefore, our pair will be x comma x plus 2. So which is equal to When x is equal to 5, I repeat, when x is equal to 5, x plus 2 is 7. So 5 comma 7. And the other pair, when x is equal to 7, x plus 2 is 9. 7 comma 9. That's it. I hope this is clear why it is not taken. And if you want to cross your solution also, whatever the data they said, you can match. They said what? Both of which should be smaller than 10. Yeah, 5, 7 and 7, 9. Both are smaller than 10. And the sum should be more than 11. Come on, find the sum of this. 5 plus 7 will be 12, more than 11. 7 plus 9 will be 16, more than 11. Okay, make a note of this. This is a 3-marker question. As an assignment, you can take the same problem in place of what? Odd, take as even and get the answer. Okay, till here no change, till here no change, only this one you have to change. Make a note of this. Okay, dear students, let's move on to the last model question paper 3 and part 1, 1-marker question. Question says the diagram represents two simultaneous linear inequalities. Simultaneous will be used whenever it is more than one equation. In this case, it is inequalities. So, two simultaneous linear inequalities on a number line. Which of the following inequalities is the solution? So, again coming to simultaneous, even in the school days, two equation, two unknown, that we call system of simultaneous equation. Correct? Sorry. Now, this represents which solution? As soon as you see the option, see, is 2 less than minus 1? 2 less than or equal to x, x is less than minus 1. Straight away option B out. Because in interval concept we know that if a comma b is the interval, always a will be less than b. Is understood? Here you see, minus 1 is more than 2. Possible? No. Straight away option B and C, because of the logical or the concept, it is false. Now come here. Try to understand this. Open ball means value not taken. Close ball means value taken. And the arrow mark is just moving like this. So it's not stopping, it's moving on. So for this particular one, see, at minus 1, it is open. So the value for this is what? Minus 1 to infinity. I am purposefully going for this so that you understand how to understand this and write down the interval. Whereas this is no, see, this side is plus infinity and this side is minus infinity. So this is just moving this side. So it is minus infinity to 2. This stands for minus infinity open and close at 2. But you want common. You can see the common here itself, no? This part till here. Correct? Here 1 is taken for this number line 1, but for 2 it is not taken. So common is what? Common is what? Present in both. Here minus 1 is not taken, but here plus, I repeat, minus 1 is not taken here, but here it is taken. Common means what? It's not taken. So minus 1 open, comma, till 2. And going beyond 2, but beyond 2, this number line is don't have any line, means any values beyond 2. So only till 2. Close. Why? Here also value taken, here also value taken. And this is our x value, or nothing but minus 1 is less than x, less or equal to 2. Since we have closed interval, equal sign is given. Since we have open interval, we are given strictly less than. So which option? Minus 1 strictly less than x less or equal to 2. Option D is correct. Okay, I hope the things are clear. Kindly make a note. Okay, dear students, let us move on to next problem. And in model question paper number 3, the question has been asked in 2 markers. Okay. Question says solve the inequalities. This is the inequality and show the graph of the solution on the number line. Okay, no problem. Very simple question. 5x minus 3 get or equal to 3x minus 5. We have to solve the solution. Again, solve for x. So I can take this x other one side and minus 3 the other side. So 5x minus 3x get or equal to plus 3 minus 5. This will give us 2x, because signs are different, we have to subtract. 5 minus 3 is 2, x as it is. Then greater equal to 3 minus 5 will be minus 2. Now I have to divide by 2 because I want only x, so 2 being positive, inequality will not change. 2 by 2 will get cancelled. X is greater equal to minus 1. We have to plot this on number line. Here they have not mentioned x is which number. Whenever it's not mentioned, x is always a real number because we are dealing with real valued function. Don't think question is wrong. So if I plot a number line, and actually when you plot a number line, no, writing in interval form is very easy. See minus 1, minus 1. And I want greater than or equal to minus 1. As we discussed, always the number right to given number is larger than this, and left to that will be lesser than. See, reason very simple. No, you can just see, no, 0 is there, then 1 is there, then 2 is there, 3 is there, 3 is there, minus 1 is there, here, minus 2. As when we go towards the right of any number, the numbers are always going to increase. Left of the numbers are always going to decrease. Okay, greater or equal to minus 1. Greater than or equal to minus 1. So at, since I have got equal sign, at minus 1 I will close shed here, and I want greater than minus 1, nothing but right to that. So my answer will be x belongs to close interval minus 1 comma infinity. Job done. A very easy problem. Kindly make a note of this. Yes, dear students, let us move on to the last problem of this chapter. And again, this has come in 2 mark. Okay. Question says, Ravi obtained 70 and 75 marks in the first 2 unit test. Okay, sorry. Ravi obtained 70 and 75 marks in first 2 unit tests. Find the minimum marks he should get in the third test to have an average of at least 60 marks. First, recall, how are you going to calculate average? Total number of terms we are going to add divided by number of terms, correct? No, all the term whichever is there, you are going to add divided by total number of terms. So, in first 2 tests, Ravi scored 70 and 75. Find the minimum marks he should get in the third test. So, first test marks is 70. Second test marks is 75. And third we have to find. So, let the marks in third test be x. So, x. Why I am adding? They said what? Average. So, average. Number of terms are 3. So, divide by number of terms. Okay. At least, recall what's the meaning of the word at least in math language. It is greater or equal to. What about at most? It is less or equal to. Even in probability also we have discussed this. So at least greater or equal to how much? 60. See, this problem is not something new. In the school days, question used to be like this: what should be the marks scored by Ravi in the third test so that his average should be 60, provided he scored 70 and 75 marks in first 2 tests. The word at least was not mentioned. Direct, his average should be 60. Okay. Now here it is, since inequality is there, what should be the minimum marks? Nothing but the least marks for which the average can be maintained to 60. Even if you scored more than that also, average is surely more than or equal to 60. Now from here, a very easy inequality. 70 plus 75. 70 plus 75 is 145 plus x. I can cross multiply 3 here. So 3 into 60 will be 180. Then 145 plus x. Transpose this other side. X is greater or equal to 180 minus 145. Subtract this. X is greater or equal to how much? 35. Mean to say, Ravi should score minimum 35 to maintain an average of at least 60. Okay, 60 marks. This implies in the third test, in the third test, Ravi should score minimum how much? 35 marks. 35 marks to have an average of to have an average of at least 60 marks. Okay, kindly make a note of this. Dear students, these are the assignments problem from this chapter which is asked in annual board examination 2024. Make sure do the assignments problem, only then you'll be the perfect. Apart from whatever you are solving along with me, hope so you're giving a pause after I explain, copy the things. Only then no, you'll be perfect. Study well. All the very best. I'll be trying to upload more number of videos because 10th of February you have got your annual board examination coming. I will just trying to put more and more videos. I will try to complete all the chapters concept and all the 3 model question papers. Okay, all the best. Study well, hard work, give your 100%, and do share, like, subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.